So hi, my name's Ryan. I work over at UC Davis, and I was asked to, it's been really interesting hearing all the presentations, so thank you. I work in sort of a couple different environments, and this one certainly overlaps with a lot of the things that I do. But I was asked to come to talk about sort of the stepping back and thinking about the data that goes behind all the things that folks have been talking about, and potentially what Nick's going to talk about as well is like the data sets that go into this are often really disparate and all different types, and they live in lots of different places. And so how do you wrangle all that data in a way that you can move forward and actually do something with that and leverage that data? And so a similar but parallel effort that happened in the Sierra Nevadas recently in the last probably 4 or 5 years is the Sierra Nevada Meadows Clearinghouse is what it's been called. And so I just want to tell you a real quick couple-minute summary of how this data set came about and why it's been really, really pretty amazing and powerful for folks that are using it now and leveraging all the different groups that are talking about it. So essentially, this data set is, it started with a bunch of different data layers of people who had essentially mapped meadows in the Sierra Nevadas. And that included the National Park Service, different agencies, researchers, all kinds of different folks. So there's all these different data sets. The underlying root behind all of them was that they were essentially a polygon that was delineating some sort of shape of a meadow boundary. And people use different methods to do that, and they use different tools. But ultimately, the big picture was that folks realized we didn't have a map of where meadows are. And I would say similarly, tailings across California, there are lots of different layers. And so just where are things, I think, is often the best place to start. And then you can add data and all the other things to that. And so this data set was pretty amazing because it used 25, I think, by the end, different data sets. We essentially stacked all those onto each other and then delineated sort of which ones were a little bit more accurate for how they were digitized and which ones were less or coarser level, and then came up with one giant compilation that was sort of the combination of all those different layers. And it has been really amazing. So now we have this map of over 19,000 meadows in Sierra Nevada. And each of those has its own metadata associated with it, size and drainage and pictures and assessments and all kinds of different things. And it's publicly available. You can sign on. We have a bunch of different things that this has been used for. And so I just wanted a sort of overview of the different data sets, putting them into one place and in one data set that people could use was the main goal. And then providing an open location where all the information about this data set could be accessed, right? So instead of having to go to 9 different websites or track down, various people, it was nice to sort of build one place where this all could live. And then people can update that. So the cool thing is we had somebody who helped us build this really amazing website that now anyone can log in. You set up a login, which is just your email, essentially. And then you have access to download all this stuff free. There's nothing else. The only thing we take an email for is to let you know when there's been updates to the Meadows database. And people put reports, protocols, projects, assessments, monitoring tools, all kinds of different things like that. And really what has been amazing is this effort started, wow, it's been a while now, 2013, 12, somewhere in there. It's been a while. And it was funded out of a National Fish and Wildlife fund that sort of kickstarted all of this. And so now I just wanted to show you, here's a map of all the different meadows by acres, by size. You can see they're definitely non-uniform and they're all over the place. After the first iteration, the Forest Service went back and actually did digitization, heads-up digitization of every single meadow to sort of make it even better, to make it more accurate, and add a lot of meadows that had not been in the original data set. And so that kind of continues these different iterations. So now we have 19,000 meadows. There's attributes for each on soil, the catchments, geology, shape, flow, various things like that. And then we are sort of actively trying to keep track of different monitoring restoration projects that are happening. Some are really old, some are new, some are, you know, upcoming. And then assessments, which has been done by American Rivers, has been great about going out, and there's a sort of a rapid assessment that they do every year in a number of these sort of monitoring meadows, which has been really cool to see that data collected as well. And then some reports and resources. So rather than showing you slides of the website, I'm just gonna jump over to the actual website. This is the website, meadows.ucdavis.edu. I encourage you to go check it out. There's all kinds of cool stuff here. I have a kind of a different little bar up here because I'm logged in, which you will see too when if you set up a email with us. But the main thing, the most important thing I think that is really useful is this Meadows map. And it takes a minute to load because there's a lot of data in it. But let me move this bar out of the way. But what's neat is you can see all these tiny little dots in here are individual meadows. And if you zoom in, you can actually see, you know, click on one of these, and every single meadow has its own web page, which is pretty crazy, and it's linked. So you can look over here. We have different meadows data sets. There's people with bird data. We've put some other interesting layers, but if you click on one of these meadows, it will actually take you to the page of that meadow and give you any information about that we have. And I think it's really powerful. It's been great. And ultimately, I would say, stepping back again, this data set has been used to build a prioritization tool to build in climate sort of resilience. Like if we're going to do restoration, where do we do it? What are we going to prioritize? Which meadows should we do that at? And based on what resources, right? You know, depending on if you're managing for frogs or birds or riparian vegetation, whatever it is, there's a tool now that has been built, which is pretty amazing, that's being used actively by a number of various groups. So, and then if you look over here, there's a few other tabs and things with ongoing projects, the scorecard assessment, which I was talking about, resources, the actual data itself. So if you're logged in, you have access to download this whole database, which is just a giant shapefile, essentially. We're working on other ways to make this downloadable and other things like, you know, Google Earth files or other shape files that people are using. But anyway, there's a lot of information on here, and it took years to get to this point. So I do want to reiterate, like, this looks cool, but it's taken a long time. And what's really, I think, encouraging is that there's a really good group of folks that are all on this call that are talking, that probably all have different inputs and different data sets. And if you all sort of participate, I think one of the reasons this has been so successful is that for a long time, the National Fish and Wildlife Fund provided sort of some funding to have a call that we had monthly or every couple months. And anybody called in that wanted to or could, and we had updates on sort of what people were up to. And that really sort of created this core group of people that stuck through different things. And then we were able to keep tabs on what different folks were doing. We realized, oh, hey, so-and-so is doing similar stuff that we are in a different place. We should talk and collaborate. And so honestly, I think just communication was one of the best things that started a lot of this work. And continues, right? So we still have groups that have spun off for these different resource groups for management and prioritization and stuff. So that's all I've got. If folks have questions, I'm happy to chat more at length now or later. So.
Thanks, Brian. Really appreciate that. And I'll kind of take us off into the second half of this time slot. So let me get my PowerPoint up and going.
Thanks so much, Ryan. It's so cool to see how far it's come. It was so hard to convince people that, you know, what it could be. And it's so great to have that as a model right now, to talk to this other group of people about what we could create. So really appreciate you being here today and bringing that. So go ahead, Nick.
Exactly. So yeah, that's exactly it. You know, we're kind of at step one of where, you know, we see what the Sierra Meadows group were at back in 2012 or 13. You know, we have this great working group of people together, and we want to be able to create a tool that'll you know, increase this, you know, the pace and scale of meadow restoration. So let me move this bar. So today I'm going to talk about, you know, what the current state of the hydraulic mine and mine inventory as it is now. So currently, from our, you know, our list of our hydraulic mine sites consists of 4 different sources. So the first is TOMS, or the Topographic Mine Symbols Database, which is essentially just point-based GPS locations and not necessarily polygons or outlines of certain mine sites. And that was created by the California Geological Survey. The second one is from a paper written from the U.S. Geological Survey about gold-bearing gravel in the ancestral Yuba River. Third is the most exciting and what we've built upon or built from and most recently, and this is the LiDAR-derived delineations of the hydraulic mines and mine features. But that currently only exists along the Tahoe National Forest, just because that is the extent of our LiDAR layer that we have currently. And that was produced from Tahoe National Forest staff as well as Chico State graduate students. And lastly, there are some older data sets that exist outside of the LiDAR derived mine sites, but that were derived using just base satellite imagery from I believe it was 2015. And so what does that give us? And so from those 4 sites, currently we have about 456 identified hydraulic mines or mine features, not all of which have been verified or, you know, ground truth, but to an extent they live on in this database currently. And that on those 456 mines or mine sites expand across about 17,000 acres. So what does that mean? But to you know, that was, you know, again, that's only within the Tahoe National Forest for the most part. There are some outliers, but to increase the pace and scale of this the mine inventory development, Sierra Fund is proposing a goal to delineate and ground truth using the LiDAR 1 sub-watershed per year. Moving forward, you know, to date we've got 3 outlined sub-watersheds, and that's Willow Creek, Oregon Creek, and the Washington sub-watersheds, not all of which have been 100% ground truth, but those are the 3 sub-watersheds that we've begun to work on currently. So what does it mean to develop this inventory? You know, so step 1 is kind of what I was talking about, using a LiDAR layer file or raster, which you see in that first picture on the far left, where, you know, at a computer at your desk, we start to this delineation and creating, you know, essentially a spreadsheet of these different polygons in their general layout. The next step is then having partners and different organizations and agencies and volunteers ground truth these identified polygons or mine sites to, you know, say, oh yeah, okay, this is indicative of hydraulic mining activities, and just kind of ground truth what we see from the LiDAR layer. But in addition to not only just putting eyes on the scene when you're there to make sure it is a hydraulic mine site, we want to do a site characterization of the mine site of individuals, or by the individuals who visit it. And so that means creating a record, you know, for each polygon of different site features that they come across. You know, was there a water diversion? Is there a tunnel? Is there a shaft? Is there an adit? Things of that nature, just to get more of a descriptive record of the mine rather than just a shape on a map. And that descriptive record, I think it's important to make sure, you know, as we're building this record, that it's standardized and that we're all calling things, you know, calling an apple, and so that the data as it's collected is consistent and can be built upon a database that is then searchable and is mainly just consistent. So it starts to build essentially a spreadsheet, which you see to the right, of different polygons that were once identified, and now they've been ground truth and started to build upon, or to start the infancy stages of this inventory. And so what does that get you? So what you're looking at here on the left side is a map of the Willow Creek subwatershed. And this exists within the Sierra Funds documents, as well as some individuals at the Tahoe National Forest. But it starts to show you, based off orange or green, whether or not it's was on a newly identified using LIDAR or LIDAR base map, or recently discovered, and then whether or not it was visited and ground truth and documented. So, but to build upon that and make this database more usable, increase the utility of it, we want to do something like it's a searchable database, or to create this prioritization tool to increase our effectiveness for remediation, or help narrow down our choices. And so what does that look like? Kind of like what you see here, which in the center of the screen is a screen grab of what I'll take you to next. It's is our version of the Sierra Meadows map, or their that you can explore and interact with. And so as you hover your mouse over one of the green outlines, which I'll take you to next, a list of attributes pops up. And what an attribute is essentially just a descriptive qualifier. In this case, it says like its name, its source, the date, who owns it, the acreage, some very simple descriptive qualities of each mine map, or of each hydraulic mine. But what we're saying is, when you're doing these site characterizations, we can then start to build out that attribute table so that it can include a larger set of information. It can be anything from fire risk, presence or non-presence of endangered species, has it been surveyed for Section 106 eligibility, and then even in the historic records, the years of operation, the type of methodology used. Maybe we know one type of hydraulic mining practice during a certain year was less efficient in retaining the mercury. So we can start to prioritize our efforts in looking and filtering out essentially which mines we want to approach in a remediation sense. So bear with me for a sec, and I will take us to its beginning stages of our searchable map. And again, our pilot approach focused on the Trapper project in general. So let me take us here. So what you can see here is the beginning stages of what Ryan kind of walked you through essentially. We have, it looks very similar. It's not embedded within a website. It's just the map itself, but you can do different things like, change the base maps, or you can change or add different data layers. And so we can add in layers, of land ownership or fuels risk, of things of that nature, and that will further help us evaluate, our pursuit of remediation. And then this is kind of where I was showing you earlier, where you start to look at descriptive attributes about each hydraulic mine or mine feature that was previously identified. And again, this is just the framework of moving forward, but it's an approach of which that we think will facilitate growth within the remediation of hydraulic mines and mine features. So that Trapper project, I think Dotrick touched on it earlier. It's about 31,000 acres, or 31,000 acre planting area, with about 19,000 of national forest system. And there was 135 identified hydraulic mines or mine features currently. Not every subwatershed has been identified, so there might be some relic or previously unknown hydraulic mine sites to be found, I guess you can say. And that also contains certain portions of the Willow Creek subwatershed and all of the Oregon Creek water subwatershed that we mentioned earlier. So what happens next? There's a few things that
Nick, do you want to share your slide again, your presentation?
I do. I thought I was on it.
Yeah, I thought you thought that. I got you.
Appreciate that. So next steps, I think one of the big things that I didn't put here that Ryan pointed out is communication. I think, buy-in from the working group is huge. But in addition to that, we need to continue to ground truth these hydraulic mine sites so that we can start to build upon this data set that we have and expand its use, expand those attributes. We need to standardize or agree upon the site characterization protocol so that we're all calling, a tunnel a tunnel. We need to develop a list of relevant qualifiers, so the site characteristics. We put up, a handful of them on that slide, but at the same time, there's more, and some people might pursue certain attributes and other agencies might pursue others. So we want to make sure that it's all encompassing and has, creates the most useful tool that we can. We want to append current hydraulic mine sites and data sets attributes with identified qualifiers. So we have, a large list of hydraulic mine sites currently. I think it was 456, I think was the number, but they all currently don't have all of the attributes built within them to then fill out whether or not it has, yellow foothill yellow-legged frogs, or for example. We want to construct this prioritization tool. We want to construct the website so that it is user-friendly. We can have our members pull data sets from it and share it and view it in an efficient format. And then not only to that, we want to establish access. Who can view this data files? Is it open to the public? Is it only open to relevant agencies or organizations that want to use it? Is there a safety issue with allowing the public to see these certain hydraulic mine sites that may or may not have physical hazards? And then as well as housing the data set. There's paying for the rights for the website and the storage that it will take to run this website. And lastly, one of our biggest tools is the LiDAR layer. And currently what we've been using for delineating these hydraulic mine sites is the LiDAR extent for the Tahoe National Forest. But, there is hydraulic mining that occurred in California outside of the Tahoe National Forest. So finding a way to pursue funding and identifying funding sources to expand that LiDAR layer will help in the growth of the inventory as a whole.
Nice.